inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Tape my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profane. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush.
And welcome back to Front-End Expert. In this video, we will be looking at some syntactic sugar within JavaScript, which are simply ways to use some unique functionalities within the language to make our code more concise, a little bit cleaner, and just easier to read. So to look at this first example, we have an array with the values 1, 2, 3, and 4, and then we have a doubled version of the array. And the doubled version of the array is a call to array.map with the double function, and the double function simply takes in a number and returns that number multiplied by 2. So as a reminder, array.map is going to call the double function, passing in each value of this array, and then it returns a new array. So in this case, we end up with the array 2, 4, 6, and 8. So when we call array.map with the double function, this is a reference to this function. So by that logic, we should be able to copy this entire function and replace the reference to it with the actual function, and this should do the same thing. And in fact, it does. And this leads us into our first piece of syntactic sugar. That's that sometimes you have a function and you don't need to give it a name. You only need it for the purpose of a single callback. And we can do that with these inline functions. And then we don't even need a name here because nothing is ever calling this by the double name. So we can get rid of that name. And this is known as an anonymous function. And for a long time, this is how we did things. But there's actually a newer version of this called an arrow function. So instead of having this function keyword, we can actually completely get rid of that. And then after the parameters, simply add an arrow, which we do with the equal sign and a greater than sign. And this works roughly the same way. So you will see the output is the exact same. There are some technicalities where there are differences between arrow functions and standard functions. We will see more of that throughout the crash course. But for the purpose of these very simple functions, such as just returning number times 2, they will work the same way. Now you might be thinking, this isn't that much better. We got rid of the function keyword, but we still have this arrow. So we haven't really gotten rid of much code, but what we can do next is actually inline this all in one line. So we get rid of the return statement as well as the curly braces. And what this is going to do is it's going to make a function that implicitly returns this value. And you will see I also had to get rid of the semicolon. So we have no return statement, no semicolon, and no curly braces, and it is all on one line. And what this says is return this value. And this can only work when you only have a single line, so a single expression, and it will simply implicitly return this. So once again, this is going to do the exact same thing. And finally, when we have exactly one parameter, so not 0 parameters, not 2 or more, exactly one, we can also get rid of the parentheses around the name of that parameter. And I can save this. And once again, you can see this does the same thing. But I would argue that this code is much easier to read and much more concise than any of the versions we had before it. Now, sometimes you will also see people give names to these arrow functions by saving them in a variable. So rather than having this inlined in the map function, I could say const double equals and then set it equal to this entire arrow function. And I will fix the spelling of double here. And then we can pass this into array.map. And once again, this will work the same way. However, I would usually recommend against doing this. The reason being that when you define a variable using const, you are creating just that, a variable, and the rules of variables or constants apply when we use const and let. And the main one is going to be that with variables such as this const double, we can't access them before their initialization. So for example, if I moved this line below the array.map call, this is no longer going to work because we can't access double before its initialization, which happened after we tried to use it. But this isn't what we expect with standard functions. So most of the time I would avoid doing this just for that reason, that it's a little bit odd to not have access to your functions earlier than when you created them, which is what we expect from most programming languages and with standard named functions in JavaScript. Okay, so that's going to do it for arrow functions for now. We will see them much more throughout the crash course and get much more information on some of the unique properties of arrow functions. But for now, let's move on. So let's look at something we call destructuring assignment. So we have this array 1, 2, 3, 4, and we might want to get the values out of it and save them into variables. So for example, I could say const first and set this equal to array at 0. Maybe I would also want to do const second and set this equal to array at value 1. And there's nothing wrong with doing this. This works just as you would expect. So we can console.log first and second, and you'll see we console.log 1 and 2. However, there is a nice syntax for doing this. So rather than this first and second on 2 lines, what we can do instead is we can say const and then have brackets like we are creating an array and say first, second, and set this equal to the array. And this does roughly the exact same thing. It says get the first value in the array and set it equal to a constant with this name, and get the second value in the array and set it equal to a constant with this name. And you can see when we run this code, it does the same thing. And now one more point here is that we don't actually end up changing the array. So if we console.log the array as well, we have not removed the values from the array. We just saved them to these variables. Now you also might want to get the rest of the values just as another array. And we have an operator for that known as the rest operator, and it's going to be 3 dots. So 3 dots, and then we can say rest to give it the name rest, and we can come down here and also console.log rest. So you can see the rest constant was set to the array 3, 4, and the original array was still unchanged with 1, 2, 3, 4. And next, we can actually do the same thing, but with objects. So let's get rid of this code for a moment and say const, say person, and create an object for this person. So we can give the person a name, set this equal to Connor, and maybe we give them a website as well, and this will be front-end expert. Okay, so now what we can do is we could get the name, for instance, by saying person.name, but what we can also do is say const, and then we will use curly braces instead of the brackets because it's an object. And we put in the curly braces whichever values we want. So for example, const name, and set this equal to person. And what this will do is it will save the value of person.name into this name variable. So we can say console.log name, and you will see that the name shows Connor. And we can also rename the fields that we are saving into variables. So for example, I can rename this to first name by using the colon and then whatever I want to call it. So now we can call this by first name, and you see we get the same value. And next, we can also use the rest operator here. So I could say comma and then ... rest. And now if I console.log of rest, you will see we get an object that has the fields that we did not remove in the destructuring. In this case, that is just the field website. So we get this object that has website front-end expert. And when we destructure an object, we can also give default values in case one of the values we look for doesn't exist. So for example, I could come into here and we can choose some value that doesn't exist on the person object. So for example, let's say company. And then I can set this equal to a default value by using the equal sign and then whichever value I want. So maybe I set the company equal to AlgoExpert, and we can add a comma here. And then you'll see if I console.log company, it will be AlgoExpert. We can see that in the output here. But if I added a company onto this person object, so maybe we added company and set this equal to foo. Now you'll see the company is foo, and we are not using this default value that we defined. But for now, let's get rid of this company foo, and we can also get rid of this destructuring for a moment. And another thing we can do is we can destructure when we pass an object as a parameter to a function. So for example, if we had this function that was print name, and it takes in a person. And then we could do console.log of person.name. And we could call print name with our person, and you'll see we end up printing Connor. And this is fine. There's nothing wrong with doing it this way, but we don't even use this website in this function. So what we can do instead is we can destructure the person parameter. So instead of this, we can add the curly braces right in line with the argument, and then we can just put in the curly braces which fields we want. So in this case, all we need is name, and we can get rid of this person dot. And now we are getting the name field off of the person that we pass into the print name function. And you will see this once again works the exact same way. Okay, so next let's remove this person object and this code here. And what I want to look at is something known as the spread operator, which works very similar to the rest operator that we saw a moment ago. So what the spread operator does is it allows us to take an array and separate out the values and pass them in as separate entities. So for example, let's create a function that is add. This will take in x and y, and it will simply console.log x plus y. So we could call add and say we want array 0 and array 1. And there's nothing wrong with this. This will work, and it will console.log 3 because 1 plus 2 is 3. But what we can also do is we can add and we can spread the array. So this is going to pass in all 4 of these values to the add function. But what's going to happen is since the add function only accepts 2 parameters, the second 2 are just going to be forgotten, and we will save the first 2 values as x and y. And you can see we get 3 here. Same thing if we had no 3 and 4, we would still get 3. But if all we have is 1, we're going to get not a number because we tried to pass 1 as x, but undefined was passed for y since there was no other value in the array. So we tried to add 1 with undefined, and that returns not a number. But let's go back to our array that had 2, 3, and 4 in it. So we can also use the spread operator in some other places. So for example, with the definition of another array. So let's create one more array and call this array 2 and set it equal to 5, 6, 7. And then what we could do is we can create one final array and we can say const combined. And this could be equal to the spread of array and the spread of array 2 inside of another array. So we are creating a new array, and I need to add a third period in both of these. We are creating a new array with the values 1, 2, 3, 4 and 5, 6, 7. So now if we console.log of combined, you'll see we
devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption, breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just kicking up daisies. Got one too many quarters in my pockets. Count 'em like the 4-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep. Till I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways. And on
get this array with all of the values in it. But what's really nice here is we can actually add more values than just what we spread. So maybe at the beginning, I want to add the value 0, and maybe between the arrays, I want to add the value 4.5. And now you'll see we get that array that we just added. So we get the 0, then we get the spread of 1, 2, 3, 4, which becomes the values 1, 2, 3, 4, the value 4.5, and then the spreading of array 2, which is 5, 6, and 7. And finally, we can use this spread syntax to take infinite arguments in a function. So let's remove this code again, and we can create a new function. So let's call this function, and I'll just call this log params, because all we're going to do is log out the parameters, and maybe this takes the value of x, and then we can add a rest parameter named rest. And then what we can do is simply say console.log of x, and let's console.log rest. And now, for example, if I call log params with just the number 1, what you'll see is that we logged the number 1 and an empty array. If I called it with the number 1 and the number 2, we get the number 1 and an array with the value 2. Similarly, if I do 1, 2, 3, 4, we get the number 1, which is being set to x, and then 2, 3, and 4 all get pushed into this array called rest, and we get this array 2, 3, 4 as our output. Okay, so next, let's move on from this array example, and let's look at something called a template literal. So imagine we had this constant, so const name, set this equal to Connor, and then we wanted to console.log hello plus name. So this will console.log hello Connor. But if we had a lot of variables inside of this string, this concatenation can get hard to read. We have to remember to add these space characters, and it just becomes a whole mess. So what we can do instead is a template literal. So I'll say console.log, and we will use the backticks and say hello, like this, a capital H like the other one. And then to go into a variable, we use a $sign and then curly braces. So here I can say name, and this will do the same thing. So now you see we also get hello Connor, but this is a bit easier to read because we can see the text hello and then the name variable. And you can actually put any values inside of the curly braces. So maybe after name, I also wanted to say 1 plus 3, and it will actually evaluate this code. So it will log hello Connor and then 4. So most of the time when you have to do any concatenation of strings, I recommend to use template literals, especially if there's more than one variable that is part of that string. So if there was going to be multiple concatenations, I highly recommend you use template literals. I think it makes your code much easier to read. Okay, so now what if we wanted to give a default value to this name? Maybe this was being calculated by some other function, and it had the ability to be null or undefined. Well, what we could do is something like const default name, and set this equal to name does not equal null. And in that case, we would use name. Otherwise, we would use maybe some default name, right? And this is fine, but there's actually a much simpler syntax we can use here. And this is called the null coalescing operator. So rather than saying name does not equal null and then having this ternary, instead what we can do is name and then 2 question marks. And this does the exact same thing as that. Here. And this is called the null coalescing operator. So rather than saying name does not equal null and then having this ternary, instead what we can do is name and then 2 question marks. And this does the exact same thing as that code before. If this value is not null, it's going to use this value. And if this value is null or undefined, it will end up using this value instead. So now if we use this default name in this console log, and I will get rid of the other console log, we see the same result. However, if name was now null, then what we will get is we will get hello default name. Same thing if this was undefined, we would end up getting hello default name. But again, if we go back to some string, this is no longer null or undefined, so it's going to ignore everything after the double question marks, the null coalescing operator. We can also use question marks as something called optional chaining. So let's create another person object again. So we can say const person, and this one I will give it a company. And the company will also have a website, and I will set it equal to AlgoExpert.io. And now we can say console.log of, and let's do person.company.website. And you'll see now we console.log AlgoExpert.io. But what would happen if this company had no website? Then we're going to end up logging undefined, which is fine. But then what would happen if this person had no company? So none of this existed. Well, now we get an error message because we are trying to read the value of website off of undefined because this reads from left to right. So person is defined. That is this object. But person.company is undefined. So this is the equivalent of saying undefined.website. And obviously this does not work. So what we can do instead is use optional chaining, which allows us to put a question mark before these periods. And what this now says is if person is null or undefined, make this whole value null or undefined. But we can say null or undefined question mark dot, and instead of trying to get the website value off of null or undefined, it's all just going to return undefined. So this whole thing becomes undefined, and we could even combine this with that null coalescing operator. So I could add the 2 question marks and say foo, and now you'll see we get foo. But if I uncomment out all of this code, we get AlgoExpert.io. And of course, if we had no website, we still end up getting foo because company.website was undefined. But if we go back to this, we get AlgoExpert.io once again. So this can be super helpful if you're working with some objects that might be coming from an API or some other place in the code base, and you just want to make sure that none of the values are null and going to throw. We can use this optional chaining to go and traverse down an object and make sure that we are only getting values that exist. Or if we do get values that don't exist, we don't end up throwing and causing the web page to crash. Okay, so lastly, what I want to talk about is something called short circuit evaluation. So let's get rid of this code again. And let's say we have a constant that is should run code. And this will just be a Boolean. So let's start with this being equal to true. And then we can have some function and call this log world. And this function will just console.log hello world. Okay, so now what we want to do is we want to run this code if should run code is true. So the way we could do that is we can say if should run code, then we want to call log world. And now you'll see that we log hello world. And if we make this false, we no longer log hello world. Now, usually this is how I would recommend writing this code, but there is another way to do it, known as short circuit evaluation. So what this will look like is we will have the should run code variable, and then the and operator, so 2 and signs, and then we can call log world. And this will actually do the same thing. So if I run this, nothing happens, but if I make this true, it will log hello world. So what's happening here? Well, JavaScript reads from left to right. And when it sees the double and operator, if either of these values is false, then it knows the whole value is false, right? Because false and false is false, or false and true is also false. So if it encounters a false value here, JavaScript just doesn't evaluate the rest of the operation. So we can combine this with a function call. And essentially what happens is if this is false, it's not going to run the code after the and signs. However, if this is true, then it needs to check what is after the and operator to see if the entire thing is true. So the result is we get something very similar to what we had with the if statement, in that we only run this code if this evaluates to true. That said, again, this is a little bit of a hack, so I usually don't recommend doing this. I think it makes your code a little bit harder to read, even if it is more concise, but you will see it sometimes, so it's good to know about. But anyways, with that, that's going to be the end of this video on syntactic sugar within JavaScript. I hope you enjoyed it, and I hope you learned something new. I'll see you in the next one.